let's have a look at this example now. It says, identify whether 1.5 and 96 are terms of the sequence where Tn equals n squared minus 3n. If so, what terms are they? So, we're being given a term here, 1.5, and a second term, 96. And they're asking whether those terms would be in this sequence where each term, so we'll get a bit of a feel for this, T1 would be 1 squared minus 3 times 1, so it's 1 minus 3, which is minus 2. So our sequence starts with minus 2. Term 2 is equal to 2 squared minus 3 times 2. So that's 4 minus 6, which is minus 2. Is that right? Yeah, I can't see I've made a mistake there. And you can see I've gone on to write out what T3 would be. So 3 squared minus 3 times 3. So that's a 0. And T4, 4 squared, 3 times 4. So 16 minus 12 is 4, and I've just written etc. Now, we don't need to do that, obviously, and in the hope that somewhere we find a 1.5 and a 96. What we can do is actually set it up with n squared minus 3n equaling 1.5. Is it possible that n squared minus 3n could equal 1.5? And that's what we want to know. What is the n position where you get a 1.5? And I'll also need to solve where n squared minus 3n is equal to 96. So, back to our basic algebra, what is it that we're needing to solve here? You can see there a quadratic equation. So it's n squared minus 3n minus 1.5 is equal to 0. Whoops. Which is always, quadratics are easier to solve if we've got them equal to 0. I'm not going to do this by thinking about two numbers that multiply to give negative 1.5 that add to give minus 3, because I don't know my fractional tables that well. I can see over here it's highly unlikely, but you know what, we won't always have a list of terms. As you'll see, we won't have any terms that are going to get up here around 96. So let's think about what we would do, because we don't have these terms, which is we're going to go back and solve the equation. So I think I'm going to use the quadratic formula in that n is equal to minus b, which is 3, plus or minus the square root of b squared minus 4 times 1.5 all over 2a. So it's 3 plus or minus the square root of 9 minus 6, well, that's just 3, all on 2. Now, really, I don't need to go any further. Why? Because I can see that there is no way that n out of this is ever going to be a whole number. And we've got here n must be a positive whole number. So we don't need to go any further there. So hopefully we will get a solution over here, or we're going to say that neither 1.5 or 96 are terms. We can definitely say 1.5 is not a term. So using the quadratic formula, there's no whole number solution to that quadratic either, therefore 96 can't be a term. Please note that I'd made a mistake back here. I'd missed the negative 1.5, but I've put it in now and changed that to a 15. If you were just following my notes, then you could make that correction as well.